Amina. Today's topic is about Introduction to Boolean Algebra. I'm currently studying in Sri Venkateshwara College of Engineering, pursuing my bachelor's in CSE with the specialization of cybersecurity. So let's get into the topic. Boolean algebra, it is a fundamental concept in computer science and digital electronics. It is a mathematical structure that is used to represent logical statements, and these are helpful in making decision in digital circuits. Understanding Boolean algebra is essential for grasping the functionality of digital systems. So let's get more familiar regarding Boolean algebra. It was developed by George in mid 19th century, and it has since been used extensively in computer science engineering. And the algebra is based on simple binary operations such as AND, OR, and NOT. Modern computers they work heavily on Boolean algebra for their functionality. These binary operations allow us manipulate and analyze logical statements, which are typically represented by Boolean variables that can have two possible values, true or false, which true is assigned as 1 and false is assigned as 0. By combining these operations, complex logical expressions can be constructed, enabling us to design circuits and algorithms that can solve a wide range of problems. Boolean algebra also forms the fundamental for other important concepts in computer science, such as proportional logic and truth tables. Proportional logic is a branch of Boolean algebra that deals with the relationships between logical statement. It enables us to evaluate the truth value of complex logical expressions by mapping all the possible combinations of true and false values onto truth tables. The truth table provides a systematic way to analyze the behavior of logical operations and validate the correctness of logical expressions. The introduction to general algebra. General algebra is a broad field of mathematics that deals with mathematical structures and their properties. It encompasses various algebraic structures such as groups, rings, and fields. General algebra is foundational of higher level mathematics and its application in other scientific disciplines. Groups are algebraic structures that consist of a set and an operation that satisfies certain axioms such as associativity and identity. Rings are algebraic structure that possesses two operations, addition and multiplication, which interact in a particular way. Fields are algebraic structures that further satisfy additional axioms such as existence of multiplicative inverses. The study of these algebraic structures forms the core of a general algebra. In addition to groups, rings, and fields, general algebra also includes study of other algebraic structures such as modules, vector space, and lattices. Modules are generalizations of vector space, whereas the scalars come from the ring instead of a field. Vector space, on the other hand, are algebraic structures that satisfies certain properties including closure under addition and scalar multiplication. Coming to the comparison between Boolean algebra and general algebra. First one is Boolean algebra. It is a primarily used for digital circuit design and logical operations. Boolean algebra is specialized branch of algebra that deals with binary variables, truth values, and logical gates. It is based on the operations of conjunction and, which is and, disjunction, which is or, and negation, which is not, and follows a set of axioms and rules specifically tailored for logical reasoning. Second is general algebra, applied across diverse mathematical fields and scientific disciplines, including computer science, physics, and engineering. General algebra encompasses the study of a wide range of algebraic structures, including groups, rings, fields, modules, and vector space. Boolean algebra and general algebra serve a different purpose in mathematics. While Boolean algebra is specifically designed for logical reasoning and digital circuit design, general algebra is more broad of and versatile branch that finds applications in various fields. General algebra explores a wide spectrum of algebraic structures, making it trivial in computer science, physics, and engineering. Coming to the introduction to flip-flops as storage elements, flip-flops are basic storage elements in digital electronics. They are used to store one bit of information, typically representing either 0 or 1. Flip-flops play a crucial role in building sequential logic circuits and memory units in computer science. They can be classified into different types such as SR flip-flops, D flip-flops, JK flip-flops, and T flip-flops, each with its own unique characteristics and applications. By understanding the behavior and operations of flip-flops, engineers and computer scientists can design and implement complex digital systems that rely on reliable and efficient storage of binary data. Each type of flip-flop operates based on a specific input condition and exhibits different behavior. SR flip-flops, for example, have two inputs, the set S and reset R inputs. The D flip-flops, on the other hand, has a single input called the data input. Understanding the difference between flip-flops for selecting the appropriate type for a given application, ensuring optical performance and functionality in digital systems. Now let's learn types of flip-flops. First is SR flip-flop, a fundamental type with two inputs, that is set and reset. Coming to the second one, D flip-flop has a single data input and is widely used in digital systems. And coming to the third one, JK flip-flop offers more functionality and flexibility compared to other types. Coming to the fourth one, that is JK flip-flops, unlikely other flip-flops, has two inputs, J as set and K as reset. It also has a toggle function that allows the output to change states when both inputs are high. This makes it popular choice in applications requiring frequency division and or pulse generation. Fifth is the toggle flip-flop. It is another type of flip-flop that can be used for frequently division applications. It has a single input called the toggle input. When the input is high, then the output toggles or changes the state. This type of flip-flops is commonly used in digital counter and shift registers. Now let's learn the applications of flip-flop. First is sequential logic circuit. These are used for storing and transferring data in a sequential manner. Second is memory unit, forms the basic component of memory devices in computers. Third is counters and registers. These are essential for counting and recording data in digital system. Fourth is flip-flops plays an important role in digital electronics that enables the storage and transfer of information in variety ways. They are commonly used in sequential logic circuit which operate on digital signals in a sequential manner. Coming to the comparison between flip-flops and other storage elements, flip-flops, these are used in a sequence logic circuits and memory units. The second is register, primarily utilized for data storage in CPU operations. Third is latches, provide temporary storage for data transmission and control application. Fourth is hard disk. It is a storage device that stores and retrieves data using magnetic storage. Latches, unlike flip-flops, provide a temporary storage for data transmission and control applications without the need of clock signals. They are commonly used in scenarios where real-time data processing and quick response times are crucial. However, the flip-flops are more suitable for sequential logic circuits and memory units, as they offer more precise control over data storage and transfer. Registers are generally used in support of CPU, which requires the use of commonly used variables as iteration variables. Additionally, they can help free up CPU load by providing more storage for the iterative calculations. Registers can be used to augment a computer by expanding its capabilities. So, in the conclusion, we conclude that the importance of algebra, that both Boolean and general algebra forms the basis for diverse applications in mathematics and engineering, and the significance of flip-flops. Flip-flops are indispensable in digital systems, contributing to the design and functioning of various electronic devices. Thank you for watching. Hope this was informational.